Today's lesson is on dilations. It's the first lesson here in Module 8, or Unit 8 for us. The unit is actually on similarity. So Unit 8 is a similarity unit. Dilations works in a similarity, and hopefully we'll explain throughout the unit how this fits. But dilations are a type of transformation. So this is really going to be a review of transformations, which we've done earlier in the first semester to begin the unit. Right? And so lots of information on this page. Lots of information is a review. First, if you do not remember what a transformation is, put that back down in your notes. And it's not on the slide, but a transformation is a change in size or location of a shape. And all of our changes so far have been changes to the location. Like we had translations, which meant to slide. And then we had rotations, which meant to turn. And we had reflections, which meant to flip. Right? Those are all types of isometries. So the size didn't change. And so the first thing we're going to write down here is dilations equals a change in size. And then if you want to help yourself out, you could make a little note that it means multiply. Right? That little note is actually going to help you more when you get to Algebra 2 class. But it does help you here, but hopefully a lot of what we do here will become obvious. Right? Now, the important note on this slide is scale factor. And scale factor is the amount it's going to increase or decrease by. And we're going to put that scale factor is A image, B image over AB. We got that from right here. Now, if you do not recall, A image is how I would say that, or I could say the image of A, and it is the new one. And so when I look here at the picture, I have an A right here and an A image right there, which means A, just regular old A, is the original. So this is the old or original one. And that A image is the new one. So the green one here is the new one. And so the new one goes over the old one when determining scale factor. Also, two words we're going to use quite a bit in this section if you do not know, or at least to begin this section, are enlarge and reduce. And we're simply going to say enlarge means to make bigger, and reduce means to make smaller. And so if you do not know those words, you might want to put those words down because we're going to use those in our homework problems tonight. All right, example 1. Example 1, determine whether the dilation from triangle ABC to triangle DEF is an enlargement or reduction. So that's one part of it. Then find the scale factor. So it's got two parts. Now, I'm going to point out first here, it doesn't use A and A image. And so when it gives me the roadmap, it's always going from old to new. So they're giving me the roadmap. Right? A lot of times our book will use left to right. A lot of times our book will use blue to green. Alphabetical order, our book will use to help you. But those are all things it doesn't have to do. So if it doesn't use A and A image, make sure you look at the roadmap so that you know which one is the old one and which one is the new one. So this went from blue to green. And so that meant it got smaller. which is a reduction. Scale factor. The scale factor we said is new over old. So the new one is the green one. And we want to compare the same parts. So if I compare the left side on the one, I need to compare. So they give me more than one number. I can compare like left to left or bottom to bottom, but I cannot compare like left to bottom. So 2 is on the left, compares to 6 on the left. Now, I would be done there, but it reduces. 2 goes into 2 once. 2 goes into 6 3 times, and so that ends up being my scale factor, and this is the fact that it reduced or got smaller. Now there's one for you to try on your own. Pause the video here and give it a try. Hopefully you read the map here and saw that it's getting bigger, so it's an enlargement. 6 over 4 reduces to 3 over 2, and so D is my answer. Jalal is printing a banner, all right, for his school's wheelchair tennis team based on the design shown. By what percent should Jalal enlarge his design so the dimensions of the banner are 5 times that of the original design? So somebody made this design on a computer. He wants to make it 5 times larger for a banner in like the gym. What will the dimensions of the banner? So 2 questions. What percent is 5 times bigger, and what will the dimensions be? Well, the percent that is 5 times bigger is 500% more. And then the new dimensions would be 30 inches by 70 inches. How did I get that? I took the original 6 and I multiplied by 5. 500% is just 5. Or if you knew you were multiplying by 5, change it to a percent, you would move the decimal place 2 times and make it 500%. 14 times 5 is 70. And so 500% is the percent change. The new dimensions are listed here after multiplying by 500%. All my page numbers are the old, they've changed the book, so I'm not sure they're correct. I should take them out of my slides. So I've circled here a lot of what's important. So I should probably point out that this is dilations in the coordinate plane, like the heading says, and that this is our main rule we want to get. All right? XY, so any XY coordinate from the XY plane becomes KX, KY. We're multiplying by K. Dilations are multiplying by K. Now K, what is K? K is the scale factor, and they're not going to hide that from you. On this example, they tell me right now K is 3, and so I count up, over and up, so P is 1, 3. So I got P 1, 3 just by counting. So like if this was a homework assignment, the green one would not be there, just the blue one. So I count up and over, over and up. 1 for X, 3 for Y. K is 3, so I multiply 1 times 3 is 3. 3 times 3 is 9. P image, remember this is my new one. P image is 3, 9. So they give me points here. So you're going to make a list. You're basically going to make 2 lists of points on your homework. You have your original, and then we have our new ones out here. And so how did I get there? I multiplied everything by the scale factor. They told me K is a half. So I did 1/2 of -4 is -2. Half of -5 is -2.5. Half of 0 is still 0. Half of 6 is 3. Half of 4 is 2. Half of 3 is 1.5. Right? And again, my page numbers are probably wrong. So give it a try here. What is A image going to be? The scale factor, or K, equals 3. And so you're going to multiply -2 times 3 and 4 times 3. And then for B and C, you're going to do the same thing. So you get 318 for B image and 15.9 for C image. Good luck. I hope that this video helps you with the homework. Let me know if you